All right, going to try this one more time. This is our lesson 13-3, trigonometric ratios for any angle. You're going to get a book assignment for this, and you can read through the section in your book, but I'm going to go through and do examples just like I would if we were together in class, which I really wish we were. So, in this lesson, we're going to learn about how to find the sine, cosine, tangent, cosecant, secant, or cotangent for any angle, even if it's not part of a little right triangle. The trig definitions that you've learned so far in geometry, and then again here in this class, are all based on a right triangle. You learned that sine of any angle, and we often use theta for an angle, just to remind ourselves that we're not talking about a length, we're talking about an angle. You learned that sine of theta was the opposite side over the hypotenuse. And that's great if you're talking about a right triangle. But if you're not talking about a right triangle, you need a different way to define the trig value, the ratio. So what we're going to do now is we're going to take any angle and we're going to put it in standard position, which you learned about earlier this week. So let's say this angle right here, let's call this theta. So this angle is not part of a right triangle. It's just an angle in standard position. And to define its trig values, its trig ratios, what we're going to do is we're going to put a point on the terminal side of the angle. It can be anywhere along this second or the final side of the angle. And we're going to give that point the generic coordinates x, y. And then we're also going to define the distance from the origin out to that point as r, the radius. So using those three numbers, the x and the y coordinate of a random point on the terminal side of the angle, and r, the distance from the origin to that point, we're going to be able to define all of our trig values. So sine, instead of being opposite over hypotenuse, the sine of that angle theta is going to be defined to be the y value over the radius. And it actually is a little right triangle. You don't even have to draw it, but if you look at how we would get to that point xy, we would go over x and we would go up y. And so look, we've made a little right triangle on the other side of that angle theta, and we're using the coordinates of the point x and y to get to that point, and then those become the sides of the triangle, the legs, and then the radius is the same thing as the hypotenuse. So you can see the radius is really just the hypotenuse as this little right triangle right here. So if you use that definition, then cosine of theta, instead of being adjacent over the hypotenuse, you can see that the adjacent side is the x over the radius. And then the tangent of theta, instead of being opposite over adjacent, is going to be the y value of the point over the x value of the point. And so now we have three new ways of describing sine, cosine, and tangent. Instead of using the sides and the hypotenuse of a little right triangle, we're going to use a point on the terminal side of the angle. And so this will work for any angle in any quadrant that you can imagine. It doesn't have to be part of a right triangle. All right, now the other three trig functions, which a lot of you were asking me questions about those, you were saying, what the heck is cosecant? And what the heck is secant? And what's cotangent? And I guess the Khan Academy video didn't explain that like I thought it did. They're very simple. Cosecant, secant, and cotangent are just the reciprocals of sine, cosine, and tangent. Your calculator doesn't even have buttons for them because you just use 1 over cosec, or 1 over sine. So cosecant is 1 over sine of theta, which if we're using the definition y over r, that makes this r over y. And secant is the reciprocal of cosine, so flip the ratio over and you get r over x, and cotangent is the reciprocal of tangent, so that's going to be x over y. So again, I never memorize these definitions here. I just memorize the first set because I know the reciprocals are just the flipped over versions of those. All right, so how are you going to use this to do problems today? Well, you're going to see problems like this. You're going to see find the trig values for a point on the terminal side of an angle, and it's going to be something like this. Let's go with the point xy. Let's give that point to be, oh, I don't know, let's go -4, -3, okay? So -4, -3 would be over 4 to the left and down 3. So that point would be right here. So if we draw the angle that goes to that point, this is going to be our angle right there. And if we want to find the sine, the cosine, tangent of that angle theta that's formed by the line that goes from the origin to that point, this is the point -4, -3 again. The first thing we have to do is we have to figure out how long this radius is. How far is it from the origin out to that point, the radius? The formula for finding the radius is super easy. It's just the Pythagorean theorem. You're going to do r equals the square root of x squared plus y squared. Because really, if you think about it, you've got x here and you've got y here. So there is a little triangle, a little right triangle. You're going to find the hypotenuse by doing the Pythagorean theorem. So when you square a negative number, don't let your calculator mess you up on that. If you do -4 squared with parentheses around it, you'll get the right thing. But if you do -4 squared plus -3 squared, your calculator is going to give you negative numbers. You've got to put parentheses around it, or just square it in your head. The square root of 16 plus 9 is the square root of 25. That's convenient for us. The radius turns out to be a nice even 5. So now that we know that the radius is 5, we can answer any trig ratio question that we're asked. The sine of that angle theta would be the y value over the radius. If you look at the point that we were given, the y value is -3 and the radius is 5. The radius will always be positive, by the way, guys. Cosine of theta is going to be the x value over the radius, so that's going to be -4 over 5. And tangent of theta is going to be the y value over the x value, so that's going to be -3 divided by -4, which the two negatives cancel out, so we get 3/4. I always do those three first, and then it's very easy to do the other three. Cosecant of theta, just flip that over, so that's going to be -5 over 3. Secant of theta, just flip over cosine, so that's going to be -5 over 4. And cotangent of theta, just flip over tangent, you're going to get 4 over 3. So there we go. There are the 6 trig ratios for the angle that is defined by the point -4, -3. So that's pretty easy. Find r first, and then use the x and the y value and the r that you've calculated to find the first 3 trig functions, and then flip them over and you'll have the second 3 trig functions. All right, now that works for any angle that's in any of the 4 quadrants. But what happens if your angle lands right on the x-axis or the y-axis? Those angles are what we call the quadrantal angles. It's a funny word. And of course my pen just died. So the quadrantal angles are the ones that are right on the x or y axis. So 90 degrees, 180 degrees, 270 degrees, and then 360 degrees. So those, it turns out to be a little bit different. Because what happens is, let's take 90 degrees for example. 90 degrees, which is also known as pi over 2 if you're talking in radians. So 90 degrees, if you put a point on the terminal side of that angle, like that, there's our angle, the radius is the same thing as the y-coordinate. So this is going to be over 0, and then it's going to be up y, and then the radius is exactly the same as the y value. So it's kind of weird when you start doing sine of that angle. Okay, we're calling this theta. If we do the sine of that, we get the y value over the radius, but they're exactly the same. So you're just going to get 1. And then if we do cosine of theta, the x value is 0 over the radius, so we get 0. And then if we do tangent of theta, we're going to get the y value over the x value, which is 0. Uh-oh. We come up with our first undefined trig value. You can't take the tangent of 90 degrees. Try it on your calculator. Tangent of 90 degrees, or if you're in radians, tangent of pi over 2. It's going to tell you domain error. So we get an undefined value there. Then if you flip all these over, then you've got cosecant of theta. Cosecant of theta is going to be 1 over 1. Flip it over, you still get 1. But if you try to do secant of theta, 90 degrees, you're going to get r over 0. And so you're going to get undefined again. And then if you do cotangent of theta, it was y over 0, now it's 0 over y, you're going to get 0. So when you're doing the quadrantal angles, 90, 270, 360, 180, I missed that one, you're always going to get either 1, 0, or undefined. And it's going to just depend on what quadrant. Oh, you could get -1 too. If you were going over like to 180 degrees, or if you're going down to 270 degrees, you could get -1. So -1 is another possibility. So the quadrantal angles, those come out a little bit different because the radius will be the same as either the x or the y, giving you those 1s. And then -1 also is a possibility. Okay, next part of the lesson. This is a long one. Reference angles. We talked about reference angles in the last lesson. I wanted to give you a preview of that, and in your homework on the worksheet you had to do some reference angles. So reference angles are the distance from the terminal side of the angle back to the x-axis. So if you're in the first quadrant, the reference angle just is the angle. Okay? If you're in the second quadrant, the reference angle is right here. So here's your original angle, but the reference angle is just this little piece that connects the little distance between the terminal side of the angle back to the x-axis. If you're in the third quadrant, say you have an angle that goes all the way around into the third quadrant, this little piece right here is what we call the reference angle. And then finally, if you're in the fourth quadrant, if you have an angle that lands in the fourth quadrant all the way around and it ends up in the fourth quadrant, this little piece right here is called the reference angle. The reason that reference angles are helpful is because if you're trying to find the trig value of an angle that's in the second, third, or fourth quadrant, you can just use its reference angle and find the trig value for the smaller angle, and it'll be the same for the big angle, with the exception that it might be negative. So an example of something like this is, I'm going to pick a good one here. Let's say that we wanted to find the tangent of 3 pi over 4. I'm going to do a radians problem so that you guys can get used to radians a little bit more. So 3 pi over 4. 3 pi over 4 is 1 pi over 4, 2 pi over 4, 3 pi over 4. 3 pi over 4 lands right there. Okay? So that's our theta, 3 pi over 4. And let's say I wanted to find the tangent of theta. Okay? I don't have to actually deal with 3 pi over 4. I can actually deal with its reference angle. Its reference angle is going to be 1 pi over 4 because that's how far it is. So if I picked a point on the terminal side, I'm basically just using the little right triangle that's formed by the reference angle. And so finding tangent of 3 pi over 4 is the same thing as finding the tangent of regular pi over 4, with the exception that it's going to be negative because it has a negative x value right here. It's still going to have a positive y value, but pi over 4 would actually be in the first quadrant, and so it would have a positive x value. But in this case, 3 pi over 4 is going to have a negative x value because you're going to have to go to a negative to the left to get to that point. So pi over 4 is 45 degrees. So you guys know about 45-degree angles, right? You know that in a 45, 45, 90 right triangle, the sides of the triangle have the ratio 1 to 1 to the square root of 2. So if you set it up like that, the tangent of 45 degrees, pick either one of them, is going to be opposite over adjacent. So that's going to be 1 over 1. So it turns out the tangent of 3 pi over 4 is going to be the same as the tangent of pi over 4, which is 45 degrees. So it's going to be 1 over 1. But it's going to be negative because we were in the second quadrant. And in the second quadrant, we have a negative x value. But we can just use pi over 4 or 45 degrees to find it. So we get negative 1 as our answer. So this 45, 45, 90 right triangle and the 30, 60, 90 right triangle, you're going to need to memorize those because they are the common trig values that we do all the time. Now, some teachers will tell you you have to memorize a table of trig values, but I learned it this way, and I think this is easier. If you can just memorize the ratio of a 45, 45, 90 and a 30, 60, 90 triangle, you can find any trig value for any angle that has a reference angle of 30, 60, or 45 by just drawing these little right triangles. Let me do another example for you. Let's do sine of negative 210 degrees. Okay? All right. So the sine of negative 210 degrees, if I want to figure out exactly what that value is, I'm going to go negative 210 degrees. That would be right there. Negative 210 degrees puts me into the second quadrant, and its reference angle is this little piece of angle right here, which is going to be 30 degrees because I went 180 plus 30 more to get to 210. So the reference angle equals 30 degrees, so I'm just going to find the sine of 30 degrees, and then I'll think about whether it should be positive or negative. So 30 degrees, look at my triangle right up here. Okay, if I look at my 30, 60, 90 right triangle, the sine of 30 is opposite over hypotenuse, so that would be 1/2. So opposite over hypotenuse, I get 1/2. So the sine of 210 degrees, negative 210, sorry, is also going to be 1/2, but I need to think about whether it should be positive or negative. If I'm in the second quadrant, I have a negative x value and a positive y value. So I'm okay because 210 degrees has, if I'm finding the sine, I'm talking about the y value, y over r, and so it would be positive. There's actually another thing you should memorize. And this is a little phrase that some students memorize, and it helps them when they're doing these trig values. All values of trig are positive in the first quadrant. Only sine and its reciprocal are positive in the second quadrant. Tangent is positive in the third quadrant along with its reciprocal, and cosine is positive in the fourth quadrant. So the phrase that some people remember is all students take calculus. All students take calculus, okay? So all trig functions will be positive in the first quadrant. Only sine and its reciprocal in the second quadrant. Only tangent and its reciprocal in the third quadrant. And only cosine and its reciprocal in the fourth quadrant. So all students take calculus helps you to remember. So if you can remember these three things right here, you should be able to find the trig values of any of the common angles no matter what quadrant they're in. You also have to remember SOHCAHTOA. And you have to remember which trig functions are reciprocals of each other. And so you have to remember that sine is the reciprocal, or sorry, cosecant is the reciprocal of sine, secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. So it is a lot to remember. I'll make a note sheet for you guys that I'll post for the quiz that will be coming up next week. Okay, let's do one more of these. I know this is getting super long, but let's do one more of these. Let's do cosecant of 11 pi over 4. Okay, that sounds really intimidating. First of all, it's a reciprocal function. It's in radians. It's big angle. All right, where do we even start? Okay, I always draw the angle. So 11 pi over 4. Pi over 4 are 45-degree increments. So 1, 2, 3, 4. Oops, I missed one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. That is 11 pi over 4. It goes all the way around and it ends in the second quadrant. I didn't mean to do all problems that ended in the second quadrant. That's okay. All right, so we're in the second quadrant, and the reference angle, which is this little angle right here, is going to be pi over 4. So I can find the cosecant of pi over 4. I don't need to worry about 11 pi over 4. Just use the reference angle, pi over 4. And cosecant is the reciprocal of sine. So I really need to find the sine of pi over 4, which is 1 over the sine of 45 degrees if you're more comfortable in degrees. Well, sure, we're all more comfortable in degrees. If I draw a 45, 45, 90 right triangle, it doesn't look like a 45, 45, 90, but that's okay. I know that the ratio is 1 to 1 to the square root of 2, so the sine is 1 over the square root of 2. So I get 1 over, the sine of 45 degrees is 1 over the square root of 2. And then 1 divided by a fraction, you're going to flip that bottom fraction over, you're going to get the square root of 2 over 1. So the cosecant of pi over 4 is the square root of 2 over 1, but 11 pi over 4 is in the second quadrant, and in the second quadrant we're going to have a negative x value and a positive y value. So if I remember, in the second quadrant, sine is positive there, so I don't need to change the sign on this. It's going to be the square root of 2 over 1. All right, your homework assignment is posted in the class work section on Google Classroom. The homework assignment is from your textbook this time, trying to mix it up. It's page 788 to 789. You're going to do the odd problems from 23 to 67. That's about 23 problems that you have to do. The answers are in the back of the book, and you can certainly attend one of our virtual office hours for me to go over homework problems with you. So that's it for today. Hopefully it recorded this time so I don't have to do this a third time. All right, bye guys.